Good day, everyone. Welcome back to my channel. Today, we're going to study about geometric sequences. We will derive the formula and we will answer questions and problems about geometric sequences. So, let's start by defining what is a geometric sequence. By definition, a geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called common ratio. The common ratio R can be determined by dividing term in a sequence by the term precedes it. So let's consider the geometric sequence 1, 2, 4, and 8. We can say that this is a geometric sequence if it has a common ratio. So we can get a common ratio by dividing 2 to 1. That is 2 divided by 1. The answer is 2. Then 4 divided by 2. That is 2 as well. And 8 divided by 4. That is 2 as well. So it has a common ratio of 2. So we can say that R is equal to 2. Now to get the next term, all we have to do is to multiply 2 by the term that precedes it. So 8 multiplied by 2 is 16. 16 multiplied by 2 is 32. Then 32 multiplied by 2 is 64. So this is a geometric sequence. Now let's state whether the following sequence is geometric or not. Now let's consider letter A. If we try to get the common ratio, 20 divided by 5, we get 4. 8 divided 20 is 4. And 320 divided by 80 is also 4. So 1, letter A is a geometric sequence because it has a common ratio of 4. Meanwhile, letter B is not a geometric sequence because it doesn't have any common ratio. So 19 over 12, this is not equal to each other. So therefore, it doesn't have any common ratio. That's why it is not a geometric sequence. Same as with letter C. It doesn't have any common ratio. That's why it is not a geometric sequence. Now the rule of geometric sequence. Let's consider the sequence 2, 6, 18, 54, 62, so forth until a sub n. Now if we're going to illustrate it by term, a sub 1 is 2, a sub 2 is 6, and we can get a sub 2 by multiplying the common ratio 3 to a sub 1. And the patterns will continue. Now, if we go to simplify this pattern into an exponential form, we can get this. Now, let's compare the exponent of the common ratio to the subscript of each of each term. So if it is 3, then the exponent is 2. So it's always less than 1. If it is 1, it is 0. 2, it is 1. And 3, it is 2. And the pattern continues. We consider a sub n to be the subscript or the of the term. We can say that the formula in exponential form is 2 multiplied by 3 raised to n minus 1 because it's always less than 1. Having that in mind, a sub n is equal to 2 times 3 raised to n minus 1. We can say that 2 corresponds to a sub 1 or the first term and 3 is our common ratio. Let's copy the formula. And we now have our geometric sequence formula. So this is a geometric sequence formula, wherein a sub 1 is the first term, n is the number of terms, and a sub n is the nth term, or the last term. R is the common ratio, and we can get R by this formula, a sub 2 divided by a sub 1, or a sub 3 divided by a sub 2, and a sub 4 divided by a sub 3. This equation should equal to each other. Now let's try to answer question example number 1. In this problem, we will not going to use the formula a sub n is equal to a sub 1 times r raised to n minus 1. All we need to do is for us to get the next three terms is to multiply the common ratio to the first term. So if our first term is 3, we can get the next term by multiplying 2 to 3. That is 6. 6 times 2 is 12, and 12 times 2 is 24. So that's how we get the next two terms. On the other hand, on the number 2, we have 60 times the common ratio 1 half, that is 30, times the common ratio 1 half again, that is 15, and times the common ratio 1 half, that would be 15 over 2. So we have the following sequence. On number 3, we have 2 for our first term. So 2 multiplied by root of 3, we have 2 root 3. Now 2 root 3 multiplied by square root of 3, we can get 2 square root of 9. Since 9 is a perfect square, we can say that 2 times 3, because 3 is the square root of 9. So 2 times 3 is 6. Then the next term is 6 root 3. So that's how we get the answer for this. On number 4, we have 4x as the first term. 4x times x squared, we can get 4x cubed, times x squared, we have 4x raised to 5, times x squared, we have 4x raised to 7. So that's how we get for number 4. On number 5, we have 12x. We just multiply it by 1/3, so we have 4x, we have 4x over 3, and we have 4x over 9. So that's how easy it is. Now let's proceed to example number 2. Find the indicated term in each geometric sequence. So given the first three terms of a geometric sequence, let's find the indicated term. For number 1, a sub 10. For number 2, a sub 20. A sub 9 for number 3, a sub 10 for number 4, and a sub 8 for number 5. Now let's start first with the first one. We can identify first if it is a geometric sequence if it has a common ratio. And the common ratio for this one is 1 half. Now, listing the given, we have a sub 1, or our first term as 256. Our n, the number of terms that we need to find is 10 terms, or 10. Then the common ratio is 1 half. We need to find a sub 10, as indicated in the problem. So for the solution, let's just copy the geometric sequence formula. Then substitute all the values that we have. After substitute, let's simplify this, and we get this equation. If we're going to answer this, let's just distribute this 9, and we have 1 raised to 9 and 2 raised to 9. And that will give us 1 over 512 multiplied to 256, and a sub 10 is equal to 1 half. I suggest that you allow your students, or if you're a student, that you will use a calculator to solve for this. It is has a larger number, so that's why the advice of using calculator would be beneficial. For number 2, we can say that the common ratio is 2, and we have the following given. A sub 1 is the first term is 1, n is 20, the common ratio is 2, and the we are going to find a sub 20. So you can see on example number 1, we have a fraction kind of common ratio. This one is a whole number. So this would be more easy, much easier than the previous example. So let's substitute it. 20 minus 1 is 19. Then 2 raised to 19 is 524,288. Let's multiply by 1, and we get this answer. On number 3, we can get a common ratio of negative 6. This is a negative ratio, and we have the following given. Remember that if the sign is alternating, you can always assure that the common ratio is negative. So let's go to find 9 for our n, and let's just substitute it, and we could have the following answer. For the next problem in number 2, we have this. You can get our common ratio with this. If you have problem on solving complex fraction, try to search for a video, or I'll be posting a video on how to deal with it. But for this, let me show you how to deal with it. Is 1 over 4 over 1 half. All you need to do is to copy the numerator, that is 1/4, and get the reciprocal of the denominator and multiply it. Reciprocal meaning we just interchange the number of numerator to the denominator. So we have 1/4 times 2, 2 over 1, and we have 2 over 4, or 1 half. So we have the common ratio of 1 half. Now we have the following given as a sub 1 is 1, n is 10, and r is 1 half. Then we need to find a sub 10. The solution for this is just substitute all the values, and we get just distribute 9 to 1 and 2, and simplify that, and we have 1 over 512 as our answer, as our a sub 10. Last problem for example number 2 is this. Though it is somehow intimidating for us to see a fraction, just remember the rules of the law of exponent in dividing variables with the same base and has an exponent. So x squared y divided by x, and we get as xy as our common ratio. Then let's just identify all the given, and after identifying all the given, let's just substitute that in our formula. In this part, we just distribute 7 on x and then y. So we have x raised to x times quantity x raised to 7, y raised to 7. And just add this x to x raised to 7. So we have this as our final answer. Now let's go to example number 3. Find the n term of the sequence 1, 3, and 19. When we say n term, they just want us to find the formula for this sequence. Okay, so let's do this. Now, as you can see, this sequence is a geometric sequence with a common ratio of 3. Now, list down all the things that we have now. So we have our a sub 1, which is 1, and our common ratio, which is 3, and let's find the formula for the n term. All we have to do is to substitute all the values that we have and simplify it, and we get this as our answer. To check it, let's try to solve for a sub 1 if we're going to get 1. So a sub 1 is equal to 3 raised to n minus 1, that is 3 raised to 1 minus 1, that is 3 raised to 0. So any number raised to 0 is equal to 1. So this is correct for the first term. And now let's try if it is correct for the third term. That is a sub n is equal to 3 raised to n minus 1. So we are going to get a sub 3. That is 3 raised to 3 minus 1. A sub 3 is equal to 3 raised to 2. A sub 3 is equal to 3. So that is the way on how to check if our formula for the n term is right. So this is correct. On number 4, you may find it somehow different variety of question, but in fact, it is just the same with example number 1. Or example number 2, I should say. If I'm going to write this question, I just write 4 over 25, 4 over 5, and 4, and so on until a sub 8. We only need to find what is a sub 8. So to answer that, again, let's find the common ratio by dividing the second term to the first term, and we get a common ratio of 5. Now for the given, again, I will try to discuss this first. So 4 over 5 divided by 4 over 25. All you need to do is to copy the denominator, that is 4 over 5, and multiply it to the reciprocal of the denominator. Sorry, copy the numerator and multiply it to the reciprocal of the denominator. That's it. So cancel 4. Then 5 divided by 5 is equal to 5. So that is our common ratio. Now, having that said, let's have the following given. Okay, so we have that formula. This should a sub 1 should be 25. So there's a typographical error on my given, but the solution is eventually correct. So just expound it. 7 minus 1, 8 minus 1 is 7. Then 7 raised to 5 is 78,125. Just use the calculator to solve for it. Or if you can, if you have time, you could just manually compute it. And you get an answer of 12,500. Now, this in number 5 example, on the fifth example, this is a different variety of question under geometric sequence. How many terms are there in a geometric sequence? 6, 24, 96, up to 98,304. As you can see, they're asking us of how many terms. When they ask us how many terms, they are looking for the value of n in this problem. So we have the same solution. Let's first check if it is a geometric sequence by getting the common ratio, which is 4, and list down all the given and try again to use that same formula. Substitute it and divide both sides by 6 such that the term with the part of the equation that has n will be singled out. So if we divide that, we get the value of 16,384. Now, in this case, we need to transform the 16,384 on in an exponential form wherein 4 is our base. So think of a number, or you have to do a trial and error on what number should be the exponent of 4 in order for us to get 16,384. So I already know the answer here. So by trial and error, you could say that 4 raised to 7 is equal to 16,384. Now, since our base are equal, all you have to do is to equate the exponent to each other. So then this one is easy now. You just add 1 on both sides and you can get n is equal to 8. So we know that the number of terms is 8 in this sequence. And number 6, the third term of a geometric sequence is 12, meaning this is a sub 3. And the eighth term is 384. This is a sub 8. Now the problem is find the first term, just a sub 1. We don't know what is a sub 1. And find the common ratio, which is r. We don't know what r and we don't know what is a sub 1. In this kind of example, in this kind of problem, the easiest way to do this is to solve first for the common ratio. So let's let's assign a sub k as on the lowest term possible, that is a sub 3, and a sub n to the last term. So having known this, we know that the value of our k is 3 and the value of our n is 8. Now with that, you could use this formula. This is a formula used to find the common ratio of a geometric sequence wherein any two terms are given except for a sub 1. So let's just substitute it. 8 minus 3 is 5 and 384 divided by 12 is 32. Now what is the fifth root of 32? The fifth root of 32 is 2. So we have 2 as our common ratio. After we get the common ratio, it's now time for us to solve for a sub 1. To solve for a sub 1, we will consider a sub 3 to be our a sub n. We will just neglect the 8 term. We will just use a sub 3 as our base for our last term and the value for n. Now again, copy the formula and substitute all the values. Then if you raise 2 to 2, we have 4. Then divide both sides by 4 and you will get 3 as the value of your a sub 1. So that's all for this tutorial. Thank you very much for staying until the end, and hopefully that you stay tuned for our next topic, which is the geometric mean. So bye for now.